All right, we're going to fill out our learning card on z-scores and the normal distribution and finding area under the curve. So the first thing we need to recognize is that we will only be using this if we have a distribution that is normally distributed. If we don't have a normal distribution, then we shouldn't be using z-scores. So we're going to start off by saying that we're going to use this distribution. PSAT scores are normally distributed with a mean, and here's our symbol for mean, mu, a mean of 500, and a standard deviation of 85. So our symbol for standard deviation is sigma right here. Knowing that, we can use this notation to say that we are working with a normal model that has a mean of 500 and a standard deviation score of 85. So with that said, now what do we do to answer these types of questions where we are trying to find the area underneath the bell-shaped or normally distributed curve? So let's go with this first question. What proportion of students scored below 464? Well, the first thing we want to do is we want to make a picture, draw a picture. By drawing a picture, what we can do is we can visualize what is going on. It gives us an idea of what our answer should look like. So here's what our picture will look like for this question. What proportion of students scored below 464? Here's what our picture would be. 500 is right in the middle of this bell-shaped distribution, being the mean. 464 is going to be below 500, and the area under the curve that I've shaded here in red, that's going to represent the proportion of students that scored below 464. So the second thing that we want to do is we want to standardize our score of 464. And the way that we standardize is by changing 464 into a z-score. The z-score formula that we want to use is right here. It says that z is equal to x minus the mean, mu, divided by the standard deviation, sigma. Well, the x is going to be 464, and we know from our model that the mean is 500 and the standard deviation is 85. So by changing 464 into a z-score, we are standardizing that z-score. So all I have to do is plug all of my values into my z-score formula. So z equals 464, which is my x, minus the mean, 500, divided by the standard deviation, 85, and I end up with z equals negative 0.42. Well, after I find my z-score, what I then do is ask the table or ask my calculator. So I can either use my calculator and the normal CDF function, or I can use this table to determine what the area under the curve would be. If I were looking for the area under the curve, I would take negative 0.42 and kind of play battleship here with the table. And what I would find is this. If I look right here, I've got negative 0.4 and then 0.02. So negative 0.42 matches up right here at 0.3372. So the area under the curve to the left of 464, or a z-score of negative 0.42, is 33.72%. Now, if I was going to use my calculator, what I would use is normal CDF from negative 99 to negative 0.42, and it would give me the same value. The last thing that I want to do is I want to tell my answer in context. You always want to give your answer in context. If you don't give your answer in context, you're probably going to get dinged for it and get points taken off. Your E will become a P, your P will become an I, and we don't want that. So our answer in context would say this: 33.72% of the students scored below 464. So by doing all of this, drawing a picture, standardizing by finding the z-score, then asking your calculator or your table, then giving the answer in context, this is everything that you need to do in order to answer these questions. The last two questions here, it says what proportion of students scored above 715, And then finally, what proportion of students scored between 464 and 715? So this is a below problem, this one's an above problem, and this is a between problem. They're all just slightly different. So we'll go through this second one here right now. The proportion of students scored above 715. For this question, what proportion of students scored above 750? I've drawn my picture. 715, I mean 715, not 750, but 750, yeah, 715 is right here, and there is the area that is shaded. I turned 715 into a z-score, so 715 minus 500 divided by the standard deviation of 85 gives me a z-score of 2.53. Now here's where things get a little bit different than what I had above. If I use this table, what I will find is that, sorry about the hiccup there, my phone rang and so I had to stop the video, but here we go. My z-score is 2.53. So if I look at the table, I'm going to go to 2.5 and then 0.3, and where the two cross is 90.9943. So that's 99.43%. Well, that, if you look at your picture, it's obviously this shaded area in red is not 99.43% of all the data. It's less than that. In fact, when you look at your table, the table always gives you the area to the left of the z-score that you are concerned with. So this 99.43% or 0.9943 is the area to the left of the z-score at 715. So what we need to do in order to get the area to the right, if I'm using the table, is go 1 minus 0.9943, which is 0.0057 or 0.57%. Now, if you're using your calculator, it's okay to just use normal CDF from 2.53 to 99. This is our lower boundary z-score, this is our upper boundary z-score, and we end up with 0.0057. And then I write my answer in context. 0.57% of students scored above 715. Then we have this last question. What proportion of students scored between 464 and 715, excuse me. So if I draw a picture here, I already had the red shaded on the outside, but what I want is this shaded area in the middle, this yellow area. That's between 464 and 715. Well, I've already found both of those z-scores. So since I've found both of those z-scores, what I can do is go to my calculator and use normal CDF and go from my lower z-score, which is negative 0.42, to my upper z-score, which is 2.53. And normal CDF from negative 0.42 to 2.53 gives me an area of 0.6571 or 65.71%. Now, if I'm using my table, what I'm going to do is I'm going to take the area to the left of 2.53, which is 0.9943. That would be this yellow area plus this red tail on the left. And I'm going to subtract away the area to the left of negative 0.42, which is 0.3372. So basically, this calculation right here, 0.9943 minus 0.3372, is the yellow area and the tail on the left minus the tail on the left. So 0.9943 is the area from here all the way to the left, and 0.3372 is the area from here all the way to the left. So if I subtract the two, I end up with 0.6571, which is just the area in yellow. And here's my answer in context. 65.71% of students scored between 464 and 715. So I hope this helps you understand normal distributions and how to use z-scores and how to find area under a curve. And I hope you have fun in your stats class.